My name is August Spitz, and today I want to tell you about Biosphere II and make a case as to why we should build Biosphere III. Now, I'm a huge space nerd, and I'm fascinated by the propulsion technology that we use to get to space with rockets and even land those rockets after we use them. More than this, though, I'm a firm believer that within our lifetime, we're going to be living in a science fiction era that's pretty much indistinguishable from 2001: A Space Odyssey. Well, maybe there's a few differences, but what I'm trying to say is, especially in the space sector, I believe that people are going to be living and working in space for long periods of time. So, how do we create large cities in space? In-orbit manufacturing and habitation that lets you look at the surface of Mother Earth while walking through a garden in space, separated by the vacuum only by a thin layer of glass. In this video, we're going to learn about how the ball was set rolling to the science fiction future by a theater troupe, a desert, $100 million, and a dream. In 1984, a man named John Allen and his theater troupe purchased a 3.14-acre swath of land in northern Arizona. This theater troupe, called the Theater of All Possibilities, was known to create ships, sail the world, refurbish old hotels, and dream together. Our world is full of visionaries like Allen who conceptualized our future and inspired other peoples to start building it. The difference, however, here is that this dream kind of came true. Now's a good time to clarify that the 2 in Biosphere 2 is paying respect to Biosphere 1, which is the one that we all live in here on Earth. Okay, but this wasn't thought up overnight. So why did this group of actors, not scientists, invest so much of their money, well, I mean Ed Bass's money, who was a heir to an oil tycoon, in this endeavor? Well, the plan was to build a hermetically, aka entirely sealed ecosystem. It's pretty much a large, oversized human terrarium. During construction, the facility was extensively leak-checked by dumping water all over the superstructure and observing where bubbles rose to the surface, so that by the end of the construction process, the entire facility had a leak rate lower than the International Space Station. That's only a few percent per year. The next large part of the facility was the extensive glass walls and ceiling that made up the majority of the structure. This allowed light energy in from outside to sustain plant life. The only things that would be entering or leaving the biosphere, if everything went to plan, was energy and information to the biospherians. This accurately represents what a hermetically sealed ecosystem in space would be. I mean, you can't get any air from outside, it's a vacuum. But you can call up mission control and ask for some news, in addition to getting light from the sun to feed your plants and sustain yourself. Finally, in 1991, 8 biospherians entered the large, oversized terrarium for 2 whole years. These biospherians were not only tasked with sustaining themselves through agriculture, but also preserving the other ecosystems that were inside Biosphere 2. This is because these other ecosystems are critical to their survival just as much as the agriculture. They recycle carbon dioxide and turn it back into oxygen, and they also take in a ton of energy from the outside and keep their ecosystems running full circle, just like Biosphere 1 does. The other ecosystems included an ocean with coral reef, a marsh, a rainforest, a savanna, a desert, and even a microcity, which is the place where they lived. Each of these ecosystems and all of the organisms included played a major role in preserving the balance of Biosphere 2. They were intricately designed so that no species would overpower another. However, this theory was put to the test when an invasive cockroach species broke into the biosphere right before closure in 1991. And went rampant in the human section. Within just 12 days, one biospherian had to be temporarily evacuated due to a medical issue. She was reintroduced to the biosphere shortly later, but this represented the first breach of the seal since the closure. Later in the mission, carbon dioxide levels ran so high due to unaccounted for microbes in the soil and the atmosphere's interaction with the concrete that liquid oxygen had to be pumped into the biosphere to keep the biospherians alive. Again, breaking the seal. But this time, it was much further into the mission, and with much more effect. During the second half of the mission, the biospherians couldn't produce enough food for themselves to eat, so they had to rely on seed stocks that were put into the biosphere before the closure. Additionally, biospherians split into 2 groups whose blood ran cold during the mission duration. This happened because of division when it came to policy decisions and other petty disputes. Alas, 2 years, and technically 40 minutes later, the biospherians re-emerged from Biosphere 2 and re-entered Biosphere 1. Now, this experiment is regarded by many as a failure, but let's put that into perspective. The majority of the facility's construction took place in the 80s. It was overseen by a theater troupe, though a talented one at that. Even adjusted for inflation, the entire facility's construction and operation really only cost about $500 million, which, yes, I know it sounds like a lot, but the Biosphere 2 facility is contributing lots to the aerospace industry, especially when it comes to interplanetary colonization. And in the aerospace industry, things pretty usually run over $1 billion. On top of that, construction of a Biosphere 3 in the 21st century wouldn't have to rely on an oil baron for its funding. SpaceX and NASA both are looking at Mars as a place to send humans long term, and biosphere systems could be utilized on the Red Planet. We just need one here on Earth to perfect the design. This means that the construction of Biosphere 3 could be funded by the government and private aerospace sector, which has access to the richest people in the world, aka Elon Musk, Jeff Bezos, etc. It's undeniable that the Mars age feels much closer today than in 1984, and the demand for a Biosphere 3 will rise. Finally, we must answer the question, why not just use Biosphere 2 again? Well, in addition to being technologically outdated and intended by the builders to only be the first of many biospheres which would build off of its Pathfinder flaws, it has been acquired by the University of Arizona, and its design has been changed so that it can no longer hermetically seal an atmosphere inside of it. The work at Biosphere 2 is not over, we should mention. It's serving a new purpose as a climate change research facility in addition to many more experiments taking place on the complex. With the lessons we learned from Biosphere 2, Biosphere 3 will not only be cheaper to build, easier to operate, and able to yield much more scientific data and public interest, which is a considerable factor. It'll also be able to serve as a closer analog to what we may see on Mars within our lifetimes. We are so close to the first human settlement of the Red Planet, and as a result, we have access to much more of the mission specifics that weren't available to the Biosphere 2 team. They were really just taking a shot in the dark as to what research would actually be necessary and what a Mars base would actually look like in the 21st century. So what do you think about Biosphere 2? Do you think it needs a sequel? I sure think it does, and I hope I've convinced you as well. But if you have any more questions, just ask me in the comment section below, and I'll answer it to the best of my ability. I'd also recommend reaching out to Jane Pointer on LinkedIn. She was one of the original 8 Biospherians, and she answered my questions that I had. Alright, thank you for watching. Peace.